Okay, so now I will continue the session of CSIR Net July 2024 exam. In the last two videos, maybe I mentioned this December exam. So sorry for that. It is not December. It is that recent CSIR Net exam, July 2024 exam. And today I will go to discuss an interesting problem on electromagnetism came in this exam, and I also feel it is a bit difficult to solve it in exam time. Okay, so now let's look at the problem. Okay, so the problem is you have a non-magnetic material with no free charge and no free current. The permittivity epsilon is a function of position, so epsilon is not a constant; it is a function of position. Capital E is your usual electric field, and mu naught have their usual meaning. So you have to choose that which of this expression is correct. So you can see that expressions are very cumbersome actually, and in exam time it is a bit difficult to solve this problem. So okay, let's look at the solution. So to solve this kind of problem, the first best technique I should recommend that write all the Maxwell's equation and try to figure out that which Maxwell's equations are the best and appropriate for this problem to solve. So first try to write all the Maxwell's equation and then try to think about it if you really want to solve this problem in exam. Okay, so this is the first Maxwell equation, that is del dot D is rho of F, that is free charge, that is equal to 0. That is already mentioned in the question, there is no free charge. Now some of you may do a mistake that when you are trying to write Maxwell's equation, you can write del dot E is equal to rho by epsilon and that kind of thing. Normally this kind of Maxwell's equation people don't remember at the first time when trying to solve a problem, but for this kind of problem where epsilon is not a constant, you have to write this kind of Maxwell's equation, or Maxwell's equation in matter actually. So this is the first Maxwell equation, del dot is equal to rho f, and that is equal to 0. So del dot epsilon e is equal to 0. D is epsilon e, which is epsilon not e plus p. P is the polarization. So together epsilon not e and p combines to epsilon e. Epsilon is a function of position. Now carefully notice here, epsilon is a function of position and it is a scalar function, and e is a vector function. So when you have a scalar function and a vector function together put in and put inside a bracket of del, that is divergence, you have this formula, that del dot phi a, where phi is scalar and a is vector. This is the formula, that is del phi dot a plus phi del dot a. So I am using this same formula here, epsilon del dot a plus grad epsilon dot a. I should say grad epsilon because when you are talking about scalar function, this del operator is acting like a grad. So yeah, epsilon del dot e plus grad e dot epsilon is 0. So this is the first equation. Now this is the second equation, that is del cross e is minus del b del t. There is no change. And this is our third equation, that is del cross b is mu naught del d del t. Now I don't write the term jf because jf is 0, there is no free current already mentioned in the question. And here also mu is mu naught. Why mu is mu naught? It is already mentioned. You can see that this is a non-magnetic material, so you have to deal only with epsilon, not with mu. So there is no permeability. There is permittivity, but you don't have to care about permeability. So this is mu is equal to mu naught. Now you can take get a flavor of this equation, that is, if you take a del t on both sides, the second term, that is del t2 appears on the right side. So after writing this equation, you can think that if I take del t on both sides, I can get something, like you can get a flavor. So that's why I am taking del t on both sides, and then this term is del2 del t2 and d is epsilon e. So your second term, look at the options, second term is del2 del t2 epsilon e. So this term exactly appears. So we are in the right way. After writing this equation, if you take del t on both sides, you can automatically guess that you are on the right way. Okay. So now you can put this del t inside. So del b del t is equal to minus del cross e. Now use this equation. So this is del cross e with a minus sign, and this is as it is del 2 del t2 of epsilon e. Now take this minus common, and then del cross, he have this usual formula, del of del dot E minus del square E. Now this formula is a bit hard to remember actually in exam halls and in other purposes also, but if you remember you can solve it, otherwise I will recommend that not try to solve these problems in exam. Okay, so yeah, this is the formula. Now rearrange this a little bit, so you will finally arrive is this line, del square E minus mu naught del 2 del t2 of epsilon E minus grad of del dot E. Now you can use the del dot E from this equation 1. You have some formula with del dot E, and you can use this formula for of del dot E from equation 1, and you can substitute it. So after substituting this del dot E, you can get that E dot grad epsilon by epsilon. So just replace this del dot E with equation 1 with the substitution from equation 1, and you will finally arrive at the result that del square E minus mu naught del 2 del T2 of epsilon E plus grad of 1 by epsilon electric field E dot grad epsilon is equal to 0. So for this problem, option 3 is the correct option. Okay, so there is little bit of vector identity. Remember, you have to remember little bit of vector identities to solve this problem. And otherwise, if you remember the vector identities, then to the best approach to solve this problem is write the Maxwell's equation first and try to think that which Maxwell's equation can lead you to the right path. Yeah, when you try to write that del cross B is mu naught del t, and if you can think that if you take del t on both sides, then automatically you can guess that you are on the right path, because this del t2 automatically appears on the right side. Yeah, so that's it for today. Thank you everyone, and if any doubt, any suggestions for me, then absolutely welcome. Thank you very much.